Hello friends, welcome to our lecture series. I am Prakash Vedja and now start next theory of Fourier integral. The Fourier integral is the means of change of limit minus pi to pi is change in convert of minus to 12. So now function f of x is a continuous function in interval 2 L. So limit of minus L to L. So now take on minus L to L is a extended limit. So now take on a extended limit on Fourier series. So now Fourier series is f of x is equal to a0 plus summation of 1 to infinity an into cos nx plus summation of 1 to infinity bn into sin nx. Now change of limit minus L to L and put the value of a0, an and bn. So f of x is equal to value of a0 is equal to 1 upon 2l interval of minus L to L f of y into dy. Now second summation of 1 to infinity value of n is equal to 1 upon L f of y into cos n x convert to pi y upon L and dy into cos nx cos n x convert to pi x upon n. Now second round 1 to infinity 1 upon L value of n is equal to f of y sin n pi y upon L dy into sin n pi x upon L. Now common this equation summation 1 upon L and dy 1 upon L f of y dy and summation common these equations. So f of x is equal to 1 upon 2L minus L to L f of y into dy plus summation of 1 to infinity 1 upon L is a common limit is a common f of y is a common. Now cos n pi y upon L into cos n pi x upon L plus sin n pi y upon L into sin n pi x upon L into dy. Now this term same is the equation of cos x into cos y plus sin x into sin y is equal to cos x minus y. Here x angle is a n pi y upon L and y angle is a n pi x upon L. So this term is a derivative of f of x is equal to 1 upon 2L minus L to L f of y into dy. 1 upon L is a common, summation is a common, minus L to L integral is a common, f of y is common. Now this all term convert to this type of equation. So cos x angle is a n pi y upon l, n pi y upon l, and y angle type of n pi x upon l. So n pi x upon l into dy. Now common these equations, n pi upon l and n pi upon l is a common. So f of x is equal to 1 upon 2l minus L to L f of y into dy plus 1 upon L summation of 1 to infinity integration minus L to L f of y into cos n pi L is a common, y minus x is an angle, and dy. Now take the value. Now take the value of alpha 1 is equal to pi x upon l. So alpha 2 upon 2 pi upon l. So on infinity value of alpha n is equal to n pi upon l. So this value, equation number 1. So this value, type of equation number 1, this type, equation number 2. And now this term is a derivative. Del alpha n is equal to pi upon l. But value of 1 upon l, so convert to value of 1 upon l is del alpha n is equal to pi. Equation number 3. 1 upon l, 1 upon l, n pi upon l, and n pi upon l. So equation number, put the value of equation number 2 and equation number 3 in equation number 1. So now rewrite the equation number 1 of f of x is equal to 1 upon 2l minus L to L f of y into dy plus 1 upon L replace 2 del alpha n upon L. Del alpha is the last term and phi is the front. So 1 upon pi summation of 1 to infinity integration minus L to L f of y into cos n pi upon L convert to alpha n y minus x into this derivation is removed, replace to del alpha n. Question number 4. Now in equation number 4, right hand side, first term approximate to 0. So this term is a 0. So now equation number 4 is f of x is equal to 1 upon 2l. Sorry, this term is a 0. So 1 upon pi summation of 1 to infinity f of y into cos alpha n y minus x alpha n function of a, sorry, alpha n. Now function of alpha n take on interval pi by 2 to infinity. Now limit. Now change of limit of minus L to L convert into minus L to L convert into minus L to L convert into 0 to infinity, and take the overall interval of minus infinity to plus infinity. Okay, so this equation number 5, rewrite the equation of f of x 1 upon pi minus L to L convert into 0 to infinity, and summation convert into integral of minus infinity to positive infinity f of y into cos. Now alpha convert into alpha. Derivative is the change of limit y minus x. Total derivative of partial derivative. So d alpha n. Equation number 6. So equation number 6 is called of Fourier integral. So thank you so much, student, watching my video.